All right, 3-2, radians and degrees. So what we have here is a central angle. What's central angle? It's an angle where it is formed at the center of the circle, hence central angle. So let's label a few parts here. So we have, since the angle meets in the center, this will be our radius right here, right? That will be a radius. That will be a radius. No matter what it's labeled, that's going to be our radius. This right here would be whatever angle is. And then here's S. S being our arc length, okay? And the formula for this, and your book gives you this formula, theta equals S over R. Make a little note, theta is in radians. Okay, not degrees. We have a slightly different formula for degrees, okay? But with theta's in radians, it's theta equals S over R. What you might have done in your math past is S equals R theta. Okay, let's do an example of that. Let's say we have, theta is going to be equal to, I don't know. Let's say we don't know what theta is. And then let's say R is equal to 5 centimeters. S is equal to arc length is equal to, let's say it's 20 centimeters. Find theta. Well, simply put, no matter which formula you use, we'll use the second one. S equals 5 theta. Get theta by itself, divide by 5. You're going to get 4 equals theta, 4 radians, that is. Every time you're trying to find theta with this, it's always going to be in radians. All right, we're going to be converting between degrees and radians for all of these. If it's in degrees, I want radians. If it's radians, I want degrees. This is the only one that's in radians. This one right here, that's from radians. Everything else is degrees. So when we have degrees, what we're going to do is multiply degrees by pi over 180. So we have 450 pi over 180. Let's reduce it. I see the 0, so I can go straight to 45 pi over 18. Divide top and bottom by 9. 5 pi over 2. I have radians. So multiply that by 180 over pi. So when we're in radians, we're going to degrees, it's 180 over pi. When it's degrees to radians, you go pi over 180. Pi's cancel. Boom, pi over pi is gone. And I also notice I can divide top and bottom by 6, and we get 30 up the top. So it's going to be 150 degrees. Because 5 times 30 is 150. This one right here, so we're going to need to multiply negative 20, or not 20, 62.7 times pi over 180, which would get us 1.1 radians. One thing to note, if you're given a fraction or a whole number with these, I hope to get it into a whole number or a fraction form, okay? If I'm giving you a straight up decimal for degrees, then this is fine, okay? But here, I want to see a fraction answer, okay? So now we're going to find the exact value of a trig function that's in radians. Cosine of pi over 3. So your book wants you to convert to degrees and then find it, but just use your unit circle. So cosine of pi over 3, of course, is 1/2. If I can draw 1/2. There we go. And then negative 4 sine of 5 pi over 4. Your book wants you to subtract 1 from the 1 pi, that is, so that it's between 0 and 1/2 to make it easier to work with. And then we'll see what happens here. So it's going to get you pi over 4. So you're finding sine of pi over 4. And keep in mind that since you change from negative y to a positive y, we need to multiply that by a negative 1 at the end if you do it this way. So sine of pi over 4 is going to get us root 2 over 2 times negative times negative is going to be positive, so it's positive 4, getting us 2 root 2 because 4 divided by 2 is 2. If you would rather just use the unit circle and realize, oh, 5 pi over 4 is equal to negative root 2 over 2, please be my guest. That is fine. That is A-okay. All right, so we are going to solve for cosine when x is equal to pi over 6. So we're going to plug in pi over 6. That's going to get us 2 pi over 6 minus pi over 2. And that's going to get us negative pi over 6. Now, negative trig values can be hard to figure out right away. So if you do want to add 2 pi to that, anytime you have a negative trig value, add 2 pi to it. That's going to get us 11 pi over 6. Cosine 11 pi over 6 is root 3 over 2, negative 1, plus 3 over 4, times root 3 over 2. And let's make this look a little bit nicer. All right, let's multiply. We're going to get 3 root 3 over 8 plus negative 1. And then if we get a common denominator, it's going to get us negative 8 plus 3 root 3 all over 8. And that would be our solution. I appreciate you watching, and we'll see you in class. Bye-bye.